next speaker will be Edoardo Scepi of the Consorzio dei Comuni della Provincia di Bolzano, and he will talk about a project to solve the topological complexity about the National Spatial Data Catalog. Thank you, Edoardo, and the floor is yours.
Thank you, Stefano. Well, good afternoon. See, it's lunchtime, more or less, and we are here presenting this project implemented together with the Autonomous Province of Bolzano and the SIAG about the creation of a simplified basal technical cartography, the basic core project, and is realized through a simplification of the spatial model that is currently should be used in Italy for producing this kind of information layer that is the national core based on the National Spatial Data Catalog. The needs of this informative layer starts from the early year 2000 in the province of Bolzano, and the primary objective of this project was to realize technical cartography that bring the minimum set of information for efficiently represent the territorial situation of an area that can be easily updatable, possibly in self-sustainable mode, and can ensure an active management on the territory, especially regarding all the changes that can happen along an area. The simplification process was mandatory for creating this product, and we have to choose some steps for implementing. First of all was the exclusion of all the information that was already retrievable in other already structured and managed data set, like the SINFI, that is the federal network for the infrastructure, the ANCSU, the streets and house numbers, the ANOP, very nice acronym, or the C. So all the data set that was already established and managed in Italy, all the information that are duplicated were eliminated. So basically we exclude from our informative layer all these information, the geodesy and photogrammetry, the addresses due to ANSU, the underground network because of the presence of the SINFI, the administrative areas, or all the digital elevation information that can be extracted from them and other similar products. The operational methodology we decided to implement, of course, was driven through some choices we have to make. Regarding the spatial model itself, we decided to use only a bidimensional management of the geometry because, for example, the zeta value, so the altitude value of an object can be derived from, for example, product like digital terrain model or digital surface model. So we simplify the management of the geometry itself. Or, for example, using a single geometry for representing an object, because, for example, the surface of the building can be derived from the volumetric units that we use for identify the buildings on the map. Clearly, for solving the problem on how some object, how a specific object is related to the level of the ground, we add an additional information called with fantasy level relative to the ground for specifying which is the position of a specific part of the object regarding to the ground level. From the informational contents, of course, we simplify the the architectural part of the geometries, as well as we have to simplify the informational context of these new technical specification. Specifically, we reduce the number of the object classes that are present inside the national core. This was obtained, merged all the similar classes that are present, for example, industrial artifact, monument, design artifact, sport equipment, were merged all together in a new class that we call artifact. And also the number of attributes that this class was bringing together was reduced because, of course, some of the information regarding these attributes can be retrieved in other database and dataset, like, again, Scepi, ANXU, and so on. So all the attributes that are present in already established dataset was considered duplicate and was removed. So this brings us to reduce quite a lot the classes from national core to basic core. As you can see, is less than half, from 59 to 23. And these, of course, make the things much simple, okay? So when we decide how to structure all the classes of the new basic core, of course, we have to implement an ETL procedure for converting, for migrating all the objects inside the municipal and provincial topographic database here in South Tyrol from the old definition, the national core, to the new one. We decided to choose the CSIS tools of the GeoML validator packages because the GeoML catalog can enable the precise cataloging of all the spatial object classes, so the definition of all the attributes and so on, while the GeoML validator can ensure that all the data respect the spatial integrity, the topological position, and was, of course, conform to the specification we realize. The new technical specification of basic course is available in two formats. In the detailed descriptive document, a list of all the layers that are present, and of course in specification file that are the file and which we can use for creating a shapefile or whatever we need to represent physically the territory. Of course, this huge automatic transformation from national core to basic core was one of the hardest tasks of our project. Was realized using FMA tools, thanks to one of our partners, that is SIAG, that is very expert in the use of this tool. And of course, all these chain of script have to consider and fulfill some requirement. For example, the import and the mapping of the national core text spec to be able to be translated in the new basic core catalog. Of course, some script needs to be suitable for transforming geometric and semantic information from national core to basic core. Of course, some script needs to take into account validation and data cleaning. And of course, other script for re-exporting all this bunch of data and for publishing them in a specific environment that basically is a very advanced WebGIS. These, are very colored images, but these are the example of some of the script realized that, of course, you can't see anything, but just for illustrating the complexity and even for shocking a bit the audience. This, for example, is the checking script example for extracting the bunch of data for management. These are for re-importing. So we have plenty of this script. Of course, this massive automatic translation was amazing, but we need to check the result, no matter all the control that was implemented. So, based on the new platform that we are using now in South Tyrol, the MapView, we created an online editing dashboard for allowing people to interact with this new basic core layer. This dashboard has a very user-friendly interface that allows the access to all the different sections of the dashboard. We have the working list, where of course all the sessions were listed. The specification of each section, where it's possible to see the actual stage of the session that they are under working. And then an interactive map to decide where are all the sessions now in working, and for deciding where to continue the work. Of course, the editing toolbox that allows to modify, update, and correct all the information that we found on this new basic core layer. A section for creating the section that have to be worked, and of course the session for the creation of the section. This section, of course, can be worked by the editing toolbox, or it's possible to extract a tailor-made basic core QGIS project for advanced editing, let's go like this. These tailor-made projects are composed by, of course, the basic core data layer, but also some support layer like checks that are tiny corrections that are mandatory to resolve. Otherwise, it's not possible to proceed with the validation of the data. The support levels that, for example, all the cadastral information or the house numbers, as well as orthophoto or other OpenStreetMap layer. This tailor-made QGIS project has, of course, control as well as the editing toolbox and the control mask for entry information, try to avoiding as much as possible error from the most problematic component of the system, so the humans that are using. So all the fields are pre-compiled, or all the information can be chosen on a list of values. This is just a quick view of how it's easy to update cartography. Here we don't have anything, and now we import very easily all the geometry of the buildings and of the parcels directly from the cadastral level. Of course, since that we are not acting only theoretically, we realized a pilot project in the second half of 2024 involving 20 municipalities of South Tyrol that were trained on the use both of the technical specific characteristic, the dashboard, and the QGIS project. We implement an inconsistencies analysis because since that the national core wasn't updated for a long time, of course, during the translation, a lot of errors comes out. We update and we correct in the real technical work phase of this project, and we, of course, proceed with the data validation and integration that allow us also to deeply check the full potentiality of the system. The conclusion, luckily, there are many and positive, because we suppose that we can tell us that we create a model for future large-scale intervention on the ground, not only related to basic core. We do a huge step forward in the standardization of the spatial data management here in the province of Bolzano, but also can be replicated somewhere else. We create a very active participation with the municipality, and this leads us to have more precise and enthusiastic way of working on the management and that update of this very important layer that represents the actual situation on the ground. And of course, some of the best outcome that we realized that we improved the accuracy of the cartography data. We basically create an autonomous model and tools for updating this cartography information. We can use this model, of course, for cooperation among municipalities and province for streamlining and the land use planning. But one of the most important is the cost reduction, because this cartography can be updated in a self-sustainable mode directly by the municipality. Of course, we're providing benefit in management this kind of project and tools. It's lunchtime, come on. They are starving, but they can wait other 5 minutes. And of course, this basal technical vector cartography can be a tool that will be effectively used, not like the national core that due to his high level of complexity was a theoretical exercise. And of course, this lead us a future development in enlarging this system for taking into account not only the basic core, but other stuff. Let me thank very quickly SIAG, because without their support, nothing was possible, especially from the technological side, and the Autonomous Province of Bolzano for active participation, sponsoring, support, and whatever. Thank you all. If you want to know more, because I'm talking quite fast, we are in the Autumn Fair here in Bolzano for the next 2 days. So you can have a look in deep of the map view and the basic core, and that's it. Thank you for your attention.